Hi, so in today's lesson, we're actually looking at the quotient rule, and that has to do with fraction, division. Okay, so let's say you have a function u equals y equals u over v. So now to find the derivative of this function, then the y dx has to be v du dx minus u dv dx divided by v squared. So that's the difference between product rule and quotient rule. Product rule is actually plus, but this is minus over v squared. All right, let's see this simple function. Y equals 2x squared plus 5, then over 2x plus 1. So what's your u? This is our u, and this is our v. So our u now becomes 2x squared plus 5. Then our v is actually 2x plus 1. And so what's my du dx? My du dx is actually 2 multiplied by 2. What I have is I have 4x. Yes, 2 minus 1 is 1, so that's gone. 5 is 0, so that's gone. dv dx, I have 2 differentiate. If I differentiate 2x, I have 2. Then if I differentiate 1, I have 0. So that's it. So from quotient to the y dx has to be v du dx minus u dv dx divided by v squared. And so I have, what's my v? This is my v, 2x plus 1. What's my du dx? My du dx is actually 4x. Then minus, what's my u? This is my u. My u is 2x squared plus 5. 2x squared plus 5. What's my dv dx? My dv dx is actually 2 multiplied by 2. Then over v squared. What's my v? My v is 2x plus 1 all squared. So I might be tempted to actually leave my answer like this, but let me just simplify further. Open up the bracket with 4x. I have 8x squared plus 4x. Then open up the bracket with 2. I have minus into 2x squared times 2. I have 4x squared plus 5. Sorry, plus 10. 5 times 2 is 10. So I don't want to expand the denominator. I'll just leave the denominator like that. 2x plus 1 all squared. Then I'm going to have 8x squared plus 4x minus 4x squared minus times plus you have minus 10 over 2x plus 1 all squared. So correct like terms, I have this minus this. I have 4x squared plus 4x minus 10 over 2x plus 1 all squared. So this is basically the derivative of that using chain rule. So I have y dx. Okay, so that's how to use that quotient rule. And let's do another example. So let's say we have y. Let's say we have y equals 3x squared plus 3 squared divided by 2x squared plus 3. Now this is going to be our u and this is going to be our v. So our u basically is actually 3x squared plus 3 all squared, and v has to be 2x squared plus 3. So what's my du dx? My du dx is actually I'm going to do this in my head. 2 times 2, I have 2. Then differentiate this, I have 3 times 2 is 6x. Then plus 0, okay, 6x. That's times 6x. Then into 3x squared plus 3. Then all raised to power minus 1. That's minus 1. So that's left. That's gone. And so my answer is actually 12x into 3x squared plus 3. So that's your derivative of that. Then let me differentiate v. The v dx now becomes 2 times 2. You have 4. That's 4x. Okay, so from the quotient rule, I have dy dx actually equals to v du dx minus u dv dx over v squared. So what's my v? My v is actually this. That's 2x squared plus 3 multiplied by du dx. This is my du dx. 12x 3x squared plus 3 then minus what's my u? My u is actually this 3x squared plus 3. Then what's my dv dx? Is actually 4x. Then over what's my v? This is my v. X squared plus 3. So x squared plus 3 is my v. Then all squared. So I wouldn't want to simplify this further. I'll just leave my answer like this. So quotient is always very large because it has to do with fraction, and very sometimes you have function of function, so sometimes it can be very very rough. So but I'll just leave my answer like this. So this is the end to our quotient rule.